Okay, here we go. Right? The top we can't factor. Is that true? That's prime. If it's not factorable, what do we say? Leave it alone, but what do we call it? Prime, right? And this is the difference of perfect cubes. You guys had a test on that. So this is x minus 2, x squared plus 2x plus what? 4. What did we always say about this term here? What do we know about this? This is what? That's prime. Is that true? Don't we always call that prime?
Yeah.
Okay, so if this thing's prime, it means we can't factor. So if you factored it, I know some people did, it's not factorable. You factored incorrectly. This is prime. This is always prime when you use the difference or the sum of perfect cubes. Okay? So what happens now with this? You guys notice? What cancels here? The x minus 2 with the what? X minus 2. What do you have left? You got 1 over what? X squared plus 2x plus 4. You're done. That's what's left. What about this? You're going to factor completely. What do you guys notice? They're all multiples of what?
3.
Of 3, right? So when we factor, this is 3. You get what? X squared plus 3x minus 4. And then, is this multiples of 3 or 6? Okay. 6, what do you have left? Squared minus 5x plus 4. Yep, you got 2 chicken soup recipes. Okay, so now you have, don't forget, you got 3 now times, use your chicken soup recipe. I'm going to say this to you, can you factor 6 as 2 times 3? You can. Use your chicken soup recipe for the polynomial on the bottom. 2 polynomials you're factoring. Specifically the trinomials by chicken soup. So this will be x, I think that's plus 4, minus 1, x, this is 4, this is what? 1. I think they're both minus, right? Times what else? Times. So, do you notice there's multiplication? Multiplication, all these multiplications? So, even though this is a difference, this is thought of as the same term, x minus 1, x minus 1. Cancel. What else could you get away? 3. Can I get rid of the x plus 4 and the x minus 4? They're not the same. This is sum, this is difference. Circle what's left. What's that final answer? X plus 4 over 2 times what? X minus 4. You could leave the answer this way, or you could use the distributive property, and you get 2x minus 8. So either versions is the correct version. Okay, you guys okay with this? This is how you do this. What about this one? You get what? X times x plus 2 over, what's this? That's beef stew. You're going to have to use beef stew here. So, by beef stew, here's what you're going to get. 2x, x. I think it'll be 3 and what? 2, yeah, plus, and what? Minus. I think so. This is what you get by your beef stew. So what cancels? Right, times and times. You get rid of x plus 2, x plus 2. You got an x, what do you have? 2x minus 3. So you're going to get x over 2x minus 3. What do you guys got? Subtraction? Can you cancel your x's? No. See, I know you say, but I have multiplication here. Yes, but you got subtraction here. That's enough to say you can't what? Cancel. This is not what you have here. You got times and times. We could get rid of the whole term here in parentheses. So you're done. So the name of the game here is simply factoring and canceling. So let me give you a couple more interesting problems. You can have x squared minus 1 over x plus 1. Let's give you 6x squared plus 54. 4x squared plus 36. We'll do maybe something like this. We'll do the 4x squared minus 12x plus 9 over 10x squared minus 11x minus 6. Okay, guys, what do you got? Difference of perfect squares, x plus 1, x minus 1 over x plus 1. And again, you're multiplying here. What cancels? Just the x plus 1. What do you have left? Your x minus 1. Yeah. Yep, you don't have to, because you know why? I mean, it is correct if you said, hey, isn't this really, you're right, isn't this really x minus 1 divided by 1? It's true. But what's anything divided by itself? Right, 5 divided by 1 is 5, right? X divided by 1 is x. So x minus 1 divided by 1 is itself. Okay, but be careful. If it's on the bottom, you do have to put that 1. All right, so when you factor 6x squared plus 54, what do you get? You got 6. What else? Is it x squared plus 9? Okay, what about this? 4x squared plus 36? 4. X squared plus 9. Do you guys know, is there a sum of perfect squares formula? In other words, this is prime. Is that true? This is prime. There is no sum of perfect squares formula. But that's okay, because it goes away what? Anyway. So can you break 6 down? Yes, you can. It's 2 times 3. And then what about 4? 2 times 2. You got 3 over what? 2. 3 halves, and you're done. Factor and what? Factor. What do you guys notice about this one? These are 2 what? Do you have, what's the greatest common factor for each one of these? Huh? What do you guys think? Is the greatest common factor 2 for each one? It's what? A couple of beef stew scenarios. These are both beef stew. Okay, because the greatest common factor for both of these is 1. So you're going to use your beef stew recipe. Okay, so we go through beef stew. So what do you notice? Let's see. What do you know? I'm thinking there's going to be a 2x, a 2x. Oh, I think that's going to be minus 3. Minus 3. Okay, this will be 2x, 5x. Or does it really matter if I put 2x or 5x? I could put 5x and 2x. Doesn't matter. So you get 5x, 2x. Some people usually start with a 5x, but it doesn't matter. I think we'll put 3 here and what? 2. I think it's minus and plus, right? Let's double check. 15x plus negative 15 plus 4 is negative. Yep. Looks like we're okay. So what happens? Which goes away? So 2x minus 3 goes away. What do you have left? 2x over 5x plus 2. You got 2x minus 3. Over 5x plus 2. Do you guys know, does the 2's cancel? Say no. How do you know? It's plus. You are what? You're done. Okay, you guys ready? I'm going to put an asterisk around this one. Huh? It's important. This one's kind of interesting. Let me say this. If you had x minus 2 over 2 minus x, when you look at this, this is a very special problem. It shows up every so often out of the blue. You got to have this one under your belt. This is like a curveball. You got to be able to hit the curve. Okay, you know what I'm saying? You got to hit this curve. You have to identify it when you see it. What do you guys notice? What does this look like to you? Because by all of our techniques, these are prime. Can't factor them. In other words, x minus 2, you can't factor the greatest common factor. 2 minus x, you can't factor the greatest common factor. And they're done. They're both prime. But how does that look to you? Isn't that kind of a weird symmetry? This is x minus 2, and this is what? 2 minus x. You want to remember this symmetry. Now here's why. You guys ready? This is a secret. They teach you how to factor. You're going to probably have that on your final. So here we go. Pick one, the top or the bottom. It doesn't matter. I'm going to say this. Let's note. You see this 2 minus x? We can factor out a negative 1. So I'm going to show you how to factor out that negative 1. Okay, this is the idea. Now, 2 minus x, if I factor a negative 1 out, that means I'm writing as negative 1 times a what? Quotient. Is that true? This is my negative 1. That's what it means to factor out a term. You factored out a greatest common factor. You're now factoring out a negative 1. Okay? But it's negative 1 always times the quotient. How do you guys find the quotient? You guys remember how we find the quotient all the time? You take what you're trying to factor, the 2 minus x, and you divide it with the what? With the negative 1. Okay? So this becomes 2 over negative 1 minus x over negative 1. What's 2 divided by negative 1? Isn't that negative 2? What's negative divided by negative? Is that plus x? Is that true? Now, the order in which you add doesn't matter. I can write it as negative 2 plus x, or I can now write it as x plus what? What is addition of a negative? Do you guys know? What's the addition of a negative? Is that subtraction? So this is really negative 1 times x minus 2. Let's write this a little clearer. So what I'm saying, ladies and gentlemen, is we can factor out, by your process of factoring out, a negative 1. This is now negative 1 times x minus 2. In other words, x minus 2 over 2 minus x is the same as x minus 2 over negative 1 times x minus 2. What do you guys see happening now? What cancels? My x minus 2. What's left? And where's it left at? Top or bottom? So this is on the bottom. It's negative 1. But what's on top? What's 1 divided by negative 1? Is that negative 1? And you are what? Done. You factor this out. This shows up. It's called factoring out a negative 1. You've never seen it before. I just showed it to you today. And, you know, a lot of times in algebra, people say, hey, where was I supposed to learn that? Well, I guess it's here. And some algebra books put a lot of those questions in their book. Some don't put any. Some save this to actually a higher math algebra course, maybe a college algebra course, this factoring out negative 1 business. But your particular book, that's okay. That'll be 15 cents, right? Your particular book, what did your book do? It added this technique in some of your homework questions. Okay, so sometimes you see this factoring in a sort of college algebra setting. But anyway, since it's in your book, I have to show you, I guess, right? What do you think x minus 4 over 4 minus x is going to give you? Huh? If you know it, can you put it down? Yes. Can you say negative 1? All right. X minus 6 over 6 minus x. What's this? All right. Let's see if you're really awake. How about 10 minus x over x minus 10? What's this? Negative 1. Okay. How about x squared minus y squared over y squared minus x squared? Huh? You're going to guess negative 1? Let's see. Let's try to do what? Let's see if we can. Now, it doesn't matter if it's the top or bottom. We can factor out a negative anywhere we want. Let's factor out a what? Let's see what that means. I have to do what then? I have to write this as negative 1 times a quotient. Where, how do I get the quotient? Y squared minus x squared divided by what? Negative 1 is y squared divided by negative 1 minus x squared divided by negative 1. What's this? Negative y squared. What's negative divided by negative? Okay. Well, how can I write this as? X squared plus a negative y squared, or x squared minus y squared. That's my quotient. So just like before, factoring out your negative 1 reverses that sort of situation, meaning you have what? X squared minus y squared over negative 1 times what? X squared minus y squared. And what goes away? X squared minus y squared. What do you have left? Negative 1. So this is what? 1 over negative 1. What's a positive divided by negative? Negative 1. You're right. Lucky guess. It's a lucky guess, right?
Why did we factor just the denominator? How about the numerator?
You could do that too. You want to know what you'd end up with? -1. Let me give you an example. Yeah, so when you see this symmetry where it's backwards and you got the differences like this is what you can do. And you know, there's a homework question in your book. It might be something like this. I don't know, 4x squared minus 9y squared over 9y squared minus 4x squared. Don't you have that weird symmetry again? Okay, so if we went through all of this, would you want to factor the -1 out from the numerator? Let's try that out. You're going to factor out a -1. This will be written as -1 times some quotient, where we find our quotient by taking 4x squared minus 9y squared. We divide by the -1. Well, that's 4x squared divided by -1 minus 9y squared divided by negative. What's positive divided by negative? It's -4x squared. Negative divided by negative is what? Positive. Let's switch our terms now. This quotient's really 9y squared minus 4x squared. Or, let's put it all together. -1 times 9y squared minus 4x squared. Everything over 9y squared minus 4x squared. What do you have left? Just a -1.
So -1 is only when it's subtraction, but if it was addition, it would be just 1? Or is it different?
It has nothing. You won't see it that way. You have to have both this sort of backwards situation where you got subtraction for both. It has to be backwards. Yeah. Very special situation. Very special problem. Okay, you okay with this? Is that easy or hard? Huh?
Is that factor out?
Factor out a -1. Factor in the -1. Yeah, this is usually, like I said, in the college algebra setting. Okay? They really, if in my mind, what you guys really should be able to do is, you know, something like this. You know, you got a lot of problems here. How about something like 4x squared minus 4x plus 1? Right, over 6x squared plus 5x minus 4. The point I'm making is you simply have to factor and cancel, you know. So like I said, factoring is a pretty big what? It's a very big tool, and so I hope you guys spend a lot of time with that, you know. What kind of recipes are these? They both beef stew? Two beef stew problems. Okay, what do you get? I'm not sure. I think maybe it might be 2x, 2x. I think they're both -1. Yeah. And maybe a 3x, 2x. This is 8x and 3x. Yeah, plus and minus. Okay, what I'm saying is use your beef stew recipes. Okay, anybody have any questions on these? Is that easy or is that hard? Huh? What was the key idea again? It's that dreaded F word. What's the F word? Factoring.
You just got to be comfortable with factoring.
That's what I'm saying. I've been saying all along. Make that investment. That's a lifelong investment. Because you're going to see factoring in 115. Where else? 125. All other math classes, you know, above this class. So it's a very worthwhile investment. All right.